to design a process which allows water to change and to transform and to move and to be itself, fundamentally to be itself. And there was a time when Victor, fairly early in his days, built a log flume for the transport of logs down the mountain. When it came to build it, it was going to be constructed out of timber, and it was going to be a half-egg shape in the profile, so that there's this shape made out of wooden slats. And when the workers asked him, well, where they were going to build it, he said, well, now, you see the valley here, and see the river. He said, that's the way that the energies like to move in this situation, so we copy that. And one of his great adages was, comprehend and copy nature. Because nature knows best how to do things, and has known best for years. It's only human beings who decide arbitrarily to impose their own laws, or what they think are laws, which are actually only half laws. In the case of gravity, for instance, with the total negation of levity, there's the law of gravity, but there is the law of levity. In fact, there's the law of both together. So, in this log flume, which was built to follow the contours of the valley, there were slats attached to the sides of the walls on left-hand bends and on right-hand bends, so that the water was caused to rotate or to form longitudinal vortices anti-clockwise and then clockwise as it went around these bends. In this first instance, built in Steyerling, this was constructed for Prince Adolf zu Schaumburg-Lippe, who was the owner of great forest estates, and the actual length of the flume was about 2 kilometers. The water and temperature was very strictly controlled. Victor determined that in order to make the flume function properly, in order to generate the right energies, it was necessary to introduce different temperatures of water into the flume. From the surface of the water to the bottom of the holding basin, there's a thermal stratification, that the water stratifies itself according to temperature and density, so that the coldest water, the 4-degree water, is at the bottom of the basin, and gradually the water heats as it goes towards the top. And so there would have been a pipe which took bottom water out, the 4-degree water out, then another one maybe at 6 degrees, and another one taking the 9-degree water out. And these would have been introduced into the flume tangentially, so that they automatically inaugurated a spiral movement, a vortical movement, a longitudinal vortical movement, in which the coldest water would have been at the center, surrounded by the water with less density and greater temperature. The colder the water is, the more laminar its flow. That means that it's more straight line movement, although it was still screwing, it's still spiraling. And the logs, the heavy beech logs, which were otherwise called sinkers because they sunk to the bottom, were suspended in this central vortical flow, this cold water, because they were denser than the densest water, and the only place that they could be was in the center of the dense water. And they were conducted all the way down these flumes without touching the sides. And his flumes were so successful that actually about 9 of them were built. It was this phenomenon that enabled Victor to transport logs, which were heavier than water, down his log flume without touching the sides. Now, these logs were known as sinkers because normally they were heavier than water and they dropped to the bottom. But because of this centripetal, this involutionary, this inward moving from the outside towards the inside spiral movement, the densest part of the water mass was in the very center of the flow, and the logs, being denser, had to occupy the densest position, surrounded by the immediately denser water, the 4-degree water. And so in moving down the log flume, there was a suction created in front of the log because the coldest water was accelerating, which actually sucked the log along in its wake. Periodically, because of course eventually these different water temperatures mixed and tend to become a uniform temperature, Victor used to allow some water to drain out and at the same point introduce what he called energy water, which was very cold water from an adjacent spring or stream which had a temperature of about 4.5 degrees centigrade, in order to reintroduce this central charge, central mass of very cold water which would continue to accelerate. And this is really how the log flume worked. There were other factors involved which relate to the way the water was caused to rotate in anti-clockwise vortices on left-hand bends and clockwise vortices on right-hand bends. In order to do this, Victor had his workmen nail slats at an angle around the outside of the bend, the outside surface of the bend. And the water encountering these slats was imparted either a clockwise spiral or an anti-clockwise spiral, so that the effect of this was when it emerged at the surface, the log was always pushed away from the bend, so that the logs passing down this flume never touched the sides. The flume was therefore never damaged in its use, and nor were the logs, and they arrived in absolutely impeccable condition. And on the first day that it was used, one of the criteria which determined whether Victor was to be paid or not is whether the flume would deliver 1,000 solid cubic meters of timber in one day. In the first day of operation, it delivered 1,600 cubic meters of timber, and Victor Schauberger was paid. And everybody else, all the experts, were furious at the success of this, because it showed that somewhere in their hydraulic theory there was a great error, a great misunderstanding of water. And Victor used to say in this regard, how can you possibly understand how water, a living substance, can behave when the only place you test it in is in laboratories instead of out in nature, where then water acts in relation to nature's laws and not the laws that you have contrived in your places of research. Victor constructed a reservoir of water at the top, at the head of the flume. And when the time came for opening, on the opening day, the experts arrived and saw the construction of this basin, holding basin, and said that it was far too flimsy. It certainly couldn't withstand the pressure of the water and so on. And Victor gave them no answer and went down and stood right in the middle of the wall opposite where the water was going to flow in. And then he gave the signal by firing 2 shots of his carbine to signal to allow the water to rush in, which it did with tremendous force and volume. And Victor said to the people who were gesticulating, say, come back, you're going to be killed. He said, what does it matter? If I'm a fool, then I'm going to be swept away, and so will my theories at the same time. But I believe in what I'm doing. And so he stood looking over the wall, watching this water flow in. And the water actually flowed in around the sides of this egg-shaped basin. And when they converged at the far end, then they produced a counter wave which moved back in the direction of the inflowing water, which was in this instance about 4 meters high, full of mud and rocks and things, and therefore exerted a counter pressure against the incoming water, and the egg-shaped holding basin held. And the experts were absolutely dumbfounded. Why should it have done this? And they then asked him, where did you get the idea for this basin? And Victor said, well, a common chicken told me how to do it. And finally, when they calculated the strength of the wall statically, they were found to be 12 times stronger than they need have been in order to resist the inflow of water and to be able to support the basin, the sides of the basin, when it was full. So this log flume is an example of how we might construct systems for moving water where there is a continual alternation of movement, of swaying movement, with different vortical flows, so that the water is able to regenerate itself and to cool itself. Preferably these should be enclosed, so that there is also no access to the water from the sun and from extra too much heat. They timed a block of wood flowing from the holding basin down to the mill in the early morning, when the water temperatures were about 8 or 9 degrees, and it took 29 minutes to cover the distance. Later in the afternoon, they got the same block of wood over the same distance, and the water temperature had by this time risen to about 14 or 15 degrees, and the block of wood took 40 minutes to cover the distance. So that it shows that with increasing